Now we're going to work with equations that have square roots on both sides of the equal to sign. In this case, we can square, pen got thicker all of a sudden, both sides of the equation and then solve it. So if we look at number 6, there is a square root on one side and a square root on the other side. So I'm going to, let's zoom in on this problem a little bit first. There we go. Sorry if that's making you dizzy. There, gives us a little bit more room to work. So we're going to square both sides. So we have 3x minus 17 equals x plus 21. Since the square just takes away the square root. So now all I need to do is subtract x. So I have all my x's on one side. So 2x minus 17 equals 21. This problem is now looking pretty easy. Add 17. So 2x equals 38. Divide by 2. So our final answer is x equals 19. Let's try the next one. In this problem, we have the same situation. We have two square roots, one on each side of the equal sign. So we can just square both sides, and that undoes the square roots. So we have x plus 4 equals 2x minus 1. We want to get the x's on one side, so I'm going to subtract this x. So I have 4 equals x minus 1. Add 1, so 5 equals x, or x equals 5 is my final answer. Now this problem is different because we have two square roots, but they're on the same side of the equal to sign. We can't use the same tactic where we just square them both and undo the square root. But what we can do is we can add the square root of x to the other side. So we have the square root of 4x minus 3 equals the square root of x. Now this looks like the other two equations that we were working with. So again, we can square both sides to get 4x minus 3 equals x. Subtract x. So 3x minus 3 equals 0. Add the 3. So 3, oops, let's erase that. So 3x equals 3. And finally, we get our answer that x equals 1. Pause the video and try these 3 practice problems on your own. Then restart the video to see if you got them correct. Check your solution for problem number 6. Check your solution for problem number 7. Problem 8 is a little bit tricky, where first we need to add the square root of 1 minus x to the other side before we square both the radicals. So now that the square root of 1 minus x is on the other side, we can square both sides. So we have 21 minus x equals 1 minus x. Add x. And we get 21 equals 1. That's weird. What do you think the answer is if we get 21 equals 1? If you wrote no solution, you are correct. So sometimes we can get no solution as our answer. If there is a square root on one side of the equation and other terms on the other side that aren't inside of a square root, we can still square both sides of the equation to help us solve it. If we get two solutions, we need to check them both in case one of the solutions is extraneous. Now, we've talked about extraneous solutions before, but what they are is a solution that we get, but if we plug it back in, it ends up not making sense. So you have to be very careful about your solutions to these types of problems. Let's take a look at problem number 9. So here we have the square root of 6 minus x equals x. So we're still going to use our strategy of squaring both sides. So we get 6 minus x equals x squared. Now, we don't want to take the square root of both sides because that's just what we undid. So that wouldn't make sense. In this case, what we have to end up doing is adding the x and subtracting the 6 to the other side. So we have 0 equals x squared plus x minus 6. Do you remember how to solve an equation that looks like this? If you said factoring or the big X, you are correct. So we need to find two numbers that add to 1 but multiply to -6. Can you think about what those two numbers are? If you said 3 and -2, you are correct. So we are going to factor this as x plus 3 and x minus 2. Do you remember the next step to do from here for factoring? If you said take both sets of parentheses and set them equal to 0, you are correct. So we end up getting two answers. We get x equals -3 and x equals 2. But we need to check for extraneous solutions. The easiest way to check for extraneous solutions is to take your solutions, plug them back in, and if we end up with a negative on the right side of the equation, we know that it is extraneous because we are not allowed to take the square root of -9 and say that it equals -3. So x equals -3 is extraneous. It's not a real solution. But if we plug in 2, the square root of 6 minus 2 should equal 2. The square root of 4 does equal a positive 2. So x equals 2 is not extraneous. It is an actual solution to the problem. Let's take a look at number 10. So again, we're going to square both sides. So we get 3x plus 4 equals x squared. And then we're going to move everybody to one side. So we end up with 0 equals x squared minus, I added an extra squared right there. There we go. Minus 3x minus 4. So let's use the big X to help us factor. We need to find two numbers that add to -3 and multiply to -4. So that should be -4 and a positive 1. So this will factor into x minus 4, x plus 1. When we set each factor equal to 0, and solve, we get x equals 4 and x equals -1. Do you think any of these solutions are extraneous? If you said x equals -1 is extraneous, you are correct. If I took a -1 and plugged it in, we're not allowed to have the square root equal a negative, so it is extraneous. If I plug in a 4, I'm all good, because then the square root equals a positive number. And if you want to really check to make sure you did it right, you can work the problem out and say, oh yes, I must have gotten the right answer because the square root of 16 does equal 4. Pause the video and try these 2 problems on your own. Then restart the video and check your work. Take a moment and check your solution to number 9. Number 9, we had to square both sides and then move everybody over and factor. We end up getting the answers x equals 6 and x equals -7. And -7 is extraneous, so our only answer is x equals 6. Number 10 was pretty tricky, so check your answer carefully. When we square both sides, you need to make sure that you square both the 2 and the x. So you get 4x squared. Then when you move over the 1 and the 3x, we end up with 0 equals 4x squared plus 3x minus 1. Remember, you have to factor this using the smiley face method because the 4 is in front of the x. So a -x plus a 4x gives you that positive 3x in the middle that we're looking for. Then you set both factors equal to 0 and solve. So we get x equals 1/4 and x equals -1. -1 is extraneous, so x equals 1/4 is the final answer to this problem.